Good evening, Titans. This is Mr. Simpson again, and the essential question tonight is how can you solve an absolute value inequality? So today we're going to be focusing on solving absolute value inequalities. But first of all, let's just look at a couple really simple ones here. If I have an absolute value of just the absolute value of x is less than 3. If we think about what this means, remember these absolute values mean the distance from 0 on a number line. So what this is really asking are what numbers are less than 3 units away from 0 on a number line. Well, if we look at a number line, we have 0, 1, 2, 3, 4, -1, -2, -3, and -4. And we think about, okay, the distance x is from 0 on the number line has to be less than 3 units. Well, that would include these numbers, 2, 1, 0, but then also on this side. Well, we want all numbers, so we're going to put an open circle at 3, an open circle at -3, and it would make sense that it would be all these. So in solving an absolute inequality, what you're going to find out is that you have to rewrite, just like we did with equations, two inequalities. One will be exactly the way it's given to us, without the absolute values. And then if this is a less than, we're going to use the word and we'll x, and then we have to flip and change. Because if you notice, the value of x here is less than 3, but it's also greater than a -3. And again, the greater than is open towards the x, which indicates that it's greater than a -3. Alright, so we'll talk about the ors here in a moment, but that's just an example, a basic example of how we're going to solve absolute value inequalities. So here's the core concept. Again, if the absolute value is less than the number, and that number has to be greater than 0, then we have the two possibilities. We have what's inside has to be exactly the way it is without the absolute values, and then the second one, I usually would write this one second, is this way. Now, the reason they put it on this side is that way when we solve it, it's in the correct order. All right? Now, if it's a greater than, this will end up being an or. We do the exact same thing, but it's an or. And the reason it's an or, if we have the absolute value of x is greater than 2, then the numbers that are more than 2 units away from 0 on a number line, well, if we want them more than 2 units away from 0, well, here is this way. These numbers going this direction are more than 2 units away. But then also the ones starting at a -2 going to the left are also. So again, this is an or. So our two inequalities would be x is less than a -2 or x is greater than a +2. So now we're going to learn how to solve these. So if we first look, I want to make sure that the absolute value is isolated, which it is, and I also want to recognize that it's a less than, because if it's in less than, then I know it's a conjunction, and I'm going to use the word and between them. So the first one I'm going to have is x plus 7 is less than or equal to 2, and x plus 7 is greater than or equal to a -2. And now I solve, so I subtract 7. I get x is less than or equal to a -5, and subtract 7, x is greater than or equal to a -9. Now, the reason they usually write this one here first is so we have them in order. So if we look at this, we go in order from least to greatest with x in the middle, and then again, when I compare the x to the -9, the big mouth is open to the x, and here the big mouth is open to the -5. And then if you were asked to graph, we'd just go from -9 to -5, be closed and shaded in between. Alright, I'm going to erase this one and do letter B. Now, in letter B, again, it's a less than, but this time it's less than 0. Well, if it's less than 0, the absolute value can never be a negative. So there can't be an absolute value less than 0. So this is a nice one because it's just a no solution right away. And you want to recognize that right away because it's a lot of work if you don't recognize that right away. So now I'd like you to try these. I don't want you to do this last one here. Let's just do a couple of these. And so pause it for a moment and then solve these. Alright, so this first one we'd have x is less than or equal to 3.5 and x is greater than or equal to a negative 3.5. So then when I write this in order, it would be negative 3.5, the x, and 3.5. Again, the x is less than or equal to 3.5, but it's greater than or equal to. And again, the big mouth is open to the x, which makes that the greater than symbol. And then if you look at number 2, it's less than a negative. Well, again, absolute value can never be less than a negative. So these are the special ones, and it's an easy one. It's a no solution for number 2. All right, now we're going to be looking at ones that are all greater than. So when we have greater than or equal to, now we use the word or between them. So I set it up, c minus 1 is greater than or equal to 5, or c minus 1 is less than or equal to a negative 5. Again, notice how I always flip and change the sign of the number. So now I solve, I add 1, c is greater than or equal to 6, or I add 1, c is less than or equal to a negative 4. And again, the reason that in the core concepts they always put this one right here written first is so when we graph them, they'd be in the proper order. So in this case, we have the 6 here, and we have the negative 4 here. Well, it's less than or equal to a negative 4, and greater than or equal to 6. Okay? Alright, so now I'm going to do B. So I'm going to erase this one and do letter B. Now, letter B is another special case one. In this case, it's greater than or equal to a negative number. Well, what we have to remember is that an absolute value is always greater than a negative number. So in this case, we'd have all real numbers. And again, it saves you a lot of work if you can recognize that right away. Okay? Alright, so now, letter C. First thing we have to do is we have to isolate the absolute value, just like we did when we solved absolute value equations. So I'm going to subtract 1 from each side first. So I get 4 times the absolute value of 2x minus 5 is greater than 20. And now I'm going to divide both sides by that 4. I get the absolute value of 2x minus 5 is greater than 5. And now I'm ready to solve. Again, it's an or because of that. So I have 2x minus 5 is greater than 5, or 2x minus 5, flip and change. Okay, and we solve, so I'm going to add 5. I get 2x is greater than 10, divide by the 2, I get x is greater than 5, or I add the 5, and I get 2x is less than 0, divide by the 2, I get x is less than 0. So I have x is greater than 5, or x is less than 0. And if I graph this up here, I have 0 here, 5 here. It's greater than 5, or less than 0. All right? So that's solving absolute value inequalities when it's a greater than symbol. Now I'd like you to try a couple here. And again, I crossed off number 6. So if we look at these, pause it and solve these, and I'll reveal the answer. Alright, so for this first one, we should have x plus 3 is greater than 8, or x plus 3 is less than a negative 8. Again, we'd subtract the 3 and we get x is greater than 5, or subtract the 3, x is less than a negative 11. And if we graph this, again, negative 11 here, 5 here, open and greater than, and open and less than. Okay. And if you take a look at number 5, the first thing we have to do is isolate the inequality. I'm going to go ahead and erase here. We have to isolate the inequality first. So we're going to do that by adding 3 to both sides. And we're going to get the absolute value of n plus 2 is greater than or equal to a negative 3. But even after we isolated it, we have to recognize that the absolute value is greater than a negative. And an absolute value will always be greater than a negative number, which would tell me this will be all real numbers. Alright? And that's all for tonight, guys. That's solving absolute value inequalities. And we'll be looking at some applications with this in class on Monday for sure. Have a good night.